ExhaustMap is probably the least used of the operators we have examined so far in this chapter. Like switch and concat ExhaustMap only maintains one inner subscription at a time. The difference with ExhaustMap is how it handles new values being emitted when an inner subscription is already active. Where switchMap switches to the new mapped observable and concat queues it, ExhaustMap simply throws it away. For instance, if we reuse the example from the previous lesson, the first observable we subscribe to immediately. Then, when a second value is emitted from the input observable, ExhaustMap checks to see if there is an active inner subscription. Because our interval is still running, this value is just ignored. When the inner interval completes, the next value emitted from the input observable will then be mapped to a new interval and subscribed to, with the same process being repeated. Let's see how this looks in code and check out a common use case. To understand how ExhaustMap works, let's start with the first example from the last lesson with concat to see how it differs. In this example, we are mapping to an inner interval that emits 3 values, then completes due to the take operator. With concat any mapped observables will queue until the observable before it completes. So if I click 3 times quickly, we can see the first observable emits 3 values, then the second starts, and once that completes, the third observable is subscribed to. Let's swap this out to use ExhaustMap to see how its strategy for handling inner observables is unique. And we'll rerun this example. When I click, we'll see the inner interval start, and I'll click again a few times while this is running. Now when the interval stops, nothing happens. This is because ExhaustMap simply ignores any values emitted from the source while there is an active inner observable, in this case our interval. So now that the interval is no longer running, we can click and a new interval is created. Clicking again while this is running will just be ignored. So when would this be useful in a real-world scenario? Well, one example is when you have an action that can be spammed and it's not productive to initiate multiple inner observables, for instance, with a login form. If a user were to come in and type their email and password and start spamming the login button, we probably don't want to initiate multiple login requests at once. To prevent this, we could disable the button while an attempt is in flight, but we could also use ExhaustMap to ensure another request does not occur as well. Let's see how we could implement this scenario. In order to mimic a login request, I went ahead and added a function which returns an AJAX observable initiating a POST request to a free public API for testing. The email and password are just hard-coded to the required values for this API for now, but in a real-world scenario, you could pull these from the input fields. So we're going to need a stream of button clicks from our login button, and we'll be flattening this with ExhaustMap. So let's go ahead and import both ExhaustMap and FromEvent now. Next, let's create a reference to this login button. So we'll make a section called Elements, and let's create a constant called Login Button. And using document.getElementById, let's grab a reference. So we'll come over to the HTML file, and the ID is login, so let's just paste that in here. Next, we need to create a stream of login button clicks. So let's create another constant called login, and using FromEvent, we'll create this stream. So we'll pass it our login button, and the event we're listening for is click events. At this point, anytime the login stream emits a click event, we want to map to and flatten the login AJAX observable using ExhaustMap. So let's call pipe on our login stream, and we'll supply ExhaustMap. Because we are just using a demo API, we'll just supply a function mapping to the same AJAX observable each time without providing credentials. In your apps, your authentication function would probably be modifying these requests based on the user input. Now let's subscribe and log the responses to the console. When we save, we can type in an email and password, and let's hit login a few times really quickly. We can see by the response that although we hit the login button multiple times, only one response was returned. And if we go to the Network tab, we can also see only one request was ever initiated. Let's actually contrast this one last time with all other flattening strategies we have covered to make sure the behavior is clear. So if we swap out ExhaustMap with MergeMap, MergeMap will initiate both requests as they occur. So if we type in a bogus email and password and hit login twice, with MergeMap, both requests are initiated. Now, if we go ahead and change this out with switchMap, so let's change out the import, and we'll also change out the operator in the pipe method. And with switchMap, when we hit login twice quickly, the first request will be canceled as we're switching to the new observable. Concat is the last strategy, so let's switch this out with concat_map, as well as the operator in the pipe method. And concat will actually queue the more times we hit login. So if we hit login twice, we'll see the second login request begins after the first is completed. To recap, exhaustMap ignores emitted values when there is an active inner observable. You can use exhaustMap when quick subsequent emissions can be ignored, like a refresh button or even a login request. You should probably avoid exhaustMap though if cancellation is important or ignoring emissions from the source could cause undesired effects, like on saves.